Well, hello, my algebra students. We're going to be working with scientific numbers this week. The scores were so much better than past years. I'm like, woohoo! So we're going to go to scientific numbers and then work with polynomials. We're going to go back and do exponentials in 2 or 3 weeks. We'll see how it goes. Now, to change a regular number, that's what I'm going to call it, a regular number, to a scientific number, you could say, okay, 4,000 is 4 times 1,000. Then 1,000 is 10 cubed. There's 10 times 10 times 10 is 1,000. There's 3 tens in 1,000. Or another way to see it is, you move the decimal 3 times to get to 4.00. To be a scientific number, it's got to be a number between 1 and 10. It can be 1, can't be 10. Then it needs to have times 10 to a power. So if you're talking about the government, it's talking about billions and trillions now. Biden's wanting to pass $1.9 trillion. In fact, I saw once where a congressman said that if it's below $1 billion, they don't even discuss it anymore. They just pass it. So, for this one, I'm going to move the decimal till I get a number between 1 and 10. Well, that'd be 6.7. Now, this is the only case you can use a multiplication symbol for, or use an X for a multiplication symbol. Then, how many times did I move it to make it bigger? Well, I moved it 6 times. So this one, it'd be 4.6 times 10. Now, it's a positive power because it's getting bigger to get the original. So 3, 6, 9, 10 times I moved it to get 4.6. So this, 1, 2, 3, 4, so 3.5 times 10 to the 4th. Here, let's see, I need to move it. Oh, 7.89 times 10 to the 3, 6, 7, 8 times. So, here's 2 more numbers. Go ahead and change them to scientific numbers for me, please. Okay, so you'd have 6 times 10 to the 369. And this would be 4.3 times 10 to the 36910. So a lot easier not to make a mistake. If you're dealing with these huge numbers, it's so easy. In the 70s, there was always talks of older people getting Social Security checks with extra thousands on it because someone just put the number in the wrong spot. Now, what if it's a really tiny number? Well, you still move the decimal to get a number between 1 and 10. So in this case, 3 times 10. But since it's getting smaller, I have to use a negative power. And how many times did I move it? 1, 2, 3. So it's 10 to the negative 3. You have to divide by 3 tens to get 0.003. So 3 divided by 10 divided by 10 divided by 10. 10 moves it once, that'd be 0.3. This would move it to 0.03. And then this would move it to 0.003. Woohoo! So this one, I'm going to move it to 4.6 times 10 to the, how many times did I move it? Well, it's getting smaller. This is smaller, so it's negative. I'm dividing by tens. So 1, 2, 3, 4. So in science, I believe there's a number that's 10 to the negative 24th. It's so tiny. It's inside the body. So, 7.4 times 10 to the, how many times? 1, 2, 3, 4, 5, 6, 7. So that means I got to divide by 10 7 times to get to the original number. So here's 4 numbers. Go ahead and figure that out and then turn me back on. Okay, so this, move it, would be 4.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's negative because the original is smaller. You're dividing by tens to make it that size. So 8.9 times 10 to the 1, 2, 3, 4, 5. It's negative because the original is smaller. So you got to divide this by 10 to get the original. This is 1. If you want to put 1.0 times 10 to the 1, 2, 3, 4, 5, 6. And then this is 6.7 times 10 to the negative. I looked at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy cow. So the original smaller, meaning you're going to have to divide this by tens to get the original, so that's why it's negative. Okay, part 2 will be up next.